Today, I would like to talk a little bit about the what is coming next. So we heard a lot about the WeVerify plugin in the previous presentations and how it's currently being used. In the WeVerify project, we have been developing the verification assistant, which is helping, which is a newest development and an add-on to the verification plugin. So here is also a preview for those of you that may be using the older version of the plugin. This may look different. So the user interface has been redesigned, and now it looks more streamlined, and the tools are categorized according to the media that you can use to verify. So if you're verifying videos here, you can see easily which tools apply to videos, for example. So as you can see from this graphic, over the course of the WeVerify project, which is where we started around here, and then here is the first release. Over time, the number of users of the plugin has grown dramatically, and it's approaching now over 50,000 users. So today, as I said, I will talk only about the assistant, and the idea behind the assistant is that the users of the plugin were not always clear which tools should be used for their specific use cases. So the assistant, when you choose that, you begin with a simple interface where you have to decide, okay, am I going to be verifying something that I have found with a URL or something that I have locally on my computer? So this is how we begin. And today I will show you some examples of verifying some public information on URLs mainly. So the assistant basically guides the users through the verification process, and given a URL or the content locally, it will extract the relevant text and media from that, decides and redirects to the relevant verification tool. So it will do some signposting, and then it will run the extracted content against various verification tools when it can do so. And it will show some of these results inside the assistant itself. So you can then decide whether you want to continue the investigation or should there be specific areas that you should focus on. So at the moment, the assistant supports various social media sites and video platforms such as Facebook, Twitter, Instagram, and TikTok. And we're in the process of adding more as we go along. So the WeVerify is running until end of November this year, and we will continue to enrich the palette that's available through the assistant and its capabilities. So to give you some practical examples here, in this occasion, for example, I have taken a fact check that has maybe the URL has been found by the user in a tweet or somewhere else, and they want to see more about it. So this is just a sort of starter example, just to show you that in WeVerify we have developed tools for identifying and tagging the credibility of some information sources. So whether it's web pages or some social media accounts. So I'll show you some more examples of that later. But basically you can see that this information on this occasion is tagged as green because it's coming from a fact checker. And there's also some warnings related to that, and we'll dig into that in a moment. So underneath, you can see that it's already started to extract the media from the debunk, and it started to recommend some tools. So the web page is very long, so I'll scroll and show you on the next one. So this is the beginning of the page that you saw. So here you can see that the assistant is saying, okay, maybe you want to use the magnifier or the metadata forensic tool or OCR. So the magnifier, metadata, and forensic tools are from what you're already familiar from the current versions, and you already saw actually in some of the earlier examples by Hazel and others how these have been used, and Sophie. So I will just show you some of the new things where we are using some new AI methods. So firstly, when you have the URL, it will lower down, you will also see the text that has been extracted, like the information part of the text stripped of any HTML boilerplate. And then you have automatic enrichment with like named entities. So in this occasion, you can see easily what are the name of people or organizations or locations that are being talked about here. And the bigger something is, of course, it's a standard word cloud, the more mentions it has in that text. So just to unpack a little bit, what kind of information do we provide? So we know that this GANAFACT is a fact checker based on the information from the Duke Reporters Lab. And we also bring in some brief description of that. So yeah, that can be of use to the user. And then also some of the content itself is taken, the text itself is taken and is used to query something that is what in WeVerify we call the database of known fakes. So Zlatina in her presentation at the beginning today, she showed some of that briefly, and I'll bring back and show you some more examples. But basically, the database of known fakes is a database of fact checks and images and debunks that have already been published by fact checkers online, and so we can automatically match this against other such fact checks from other organizations using semantic similarity search. So this is the blockchain based database of known fakes in WeVerify. As you can see that at the beginning, at the top level, you have like a dashboard where you can see how many debunks exist per language, for example, by how many different authors, how many organizations. The organizations are hidden here. You can see how the numbers of debunks has changed over time. And here is the search interface. So you can also search it as a normal database with a normal web user interface and identify some matching information. So about COVID, for example, some debunks that have been collected. So I'll show you some more advanced and interesting results against the database of known fakes. Just one thing I need to say here about the database itself is that this database was created and populated using a combination of natural language processing techniques and semantic enrichment over the debunks. So it goes over and above in terms of content provided by standard claim review. So here we have the example again in the assistant. We have put this Facebook URL of something that we have come across Facebook, for example, and we want to see, can we fact check it? And then what we can see is that the text of this content is similar to an existing debunk in our database. But even more interestingly, what we can see is the semantic similarity search. So here, because the media has been extracted from the Facebook post itself, we can see that this image has been matched using semantic similarity, using image-based similarity search to other images in the database that have appeared in other debunks already. So now we can see that this image is very similar, and if we click, we can actually see that it is in fact the same image. So what allows us to do that is, so inside the database of known fakes, each of the debunks, this is the text of the debunk. It was done by full fact, but what we can see is that we have, as I said, using NLP techniques, we have created more additional semantic information. So we know that the review is from full fact and it's showing a picture, and this is the URL, so you can go there. However, you can also see that there is the so-called appearance. So it's pointing inside the review. There is also a link to the external Facebook URL, and from that link we're able to extract the images. So we're collecting and being able to then match with this with the image-based similarity search. And in order for you to do this, to access this kind of extended information, you need to be a registered user for the database of known fakes. And if you wish to become so, you just need to reach out to some of us. It is available for users from, well, primarily fact checkers and journalists, in fact. So we also wanted to show you how we can fact check the identify the domain and content credibility of social media accounts. So for example, if we find this TikTok URL, it is from a from the TikTok account, and what we see here is that videos, TikTok posts from this TikTok account have appeared in 3 debunks in the database of known fakes. We are in the process of extending this, so you will actually be getting here underneath the links to the actual debunks, so then you can go and see them. That's not a problem. But at the moment, it just tells you that 3 of the debunks in the database are concerned with this particular TikTok account. So what we are basically also doing is we're enriching information also from other sources. For example, published lists of non-credible sites in research papers and so on. So another tool that I wanted to highlight is the OCR tool. So in WeVerify, we developed a deep learning based tool for image and meme OCR, which we also can apply to political adverts. And here you can see it's been trialed by our users internally and externally in WeVerify to be able to extract text. In this occasion, it's from a photo of a demonstration in Spain, I think it is. And then you have here some of the text that has been extracted from these banners. And what our users said about it is that the performance of the WeVerify OCR on this particular occasion is better than the performance of the OCR of Bing and Yandex, because they couldn't recognize the non-frontal perspective and text in objects in non-frontal perspective. We are currently working on extending this for non-Latin scripts and screenshots as well, because fact checkers and others are widely using, and misinformation as well is widely using screenshots of content. So extracting the text from that is really important in order to be able to verify it and process it further. So this is just another example to show you that the same type of tool can be used to monitor misinformation in adverts. So this is an ad that we got from the Facebook transparency ad library. And here, the actual text of the advert is completely fine, but within the advert, we have this misleading claim about 40 new hospitals going to be built. Which was labeled as misleading by the full fact checker in the UK. So here you can see the output, it recognizes the text correctly. So this then means that we are able to take, for example, this text and match this, do semantic similarity search against the debunks in the database of known fakes, and then surface this kind of claims, this kind of debunks automatically. Something else that we're currently working on, it's in the process of being integrated in the assistance and the plugin. It's not there yet, is the question of what are people actually thinking about misinformation they encounter online? Are they believing it or are they not believing it? And also, what is the role of the citizen debunkers, and can they help fact checkers do their job quicker? So on this occasion, we had the French president post in August last 2019, this photo purportedly of the Amazon rainforest burning at the time. And there's something that the president said about about the picture and what was happening in the Amazon. Now, the issue is that, of course, this has received, as you can see, over 57,000 retweets and many likes, but also it has received over 1,000 replies, if I remember correctly. So a question is, amongst those thousands of replies, what are people really saying about this? And we have developed AI-based, deep learning-based tools in WeVerify to be able to detect automatically the stance and the beliefs that are being expressed in conversations. So on this occasion, we are taking each of the replies of these to this tweet of Macron and classifying it, whether it's agreeing with what Macron is saying, whether it's disagreeing, so potentially debunking it, whether it's commenting or questioning what's being said. And so on this occasion, what this allows us to do is once we do this automatically, it's possible to filter and just zoom in on the ones that are disagreeing with what's being said. And what we can quickly see in that case is that the users who have responded are saying that this picture actually is a stock photo, it's a really old photo, and so on. And they are also questioning some of the veracity of what Macron is claiming in the text. So this kind of information can be very helpful to also understand very quickly as to whether people are believing what they're encountering as misinformation and whether it's really worth going to the extent of publishing debunks and so on. So just to complete my presentation with a little teaser, and these are some new AI filters in image forensics, which are being developed and will be released soon. So here, this is part of the forensic tool. It will be updated with these new features. So basically, when you run the forensic tool, it gives you a lot of outputs, which are similar to these ones here. And users often are not sure which of these different outputs from which of these different algorithms they should be using and what should they be, what does it actually mean? So in the new extended version, using some deep learning, the idea is to be able to explain to the users and help them understand which are the areas of the image that can potentially be tampered. So section of the objects in this image highlighted in red is where they should focus on. So moreover, using these tools, these deep learning outputs, we are able to also superimpose on the image itself the areas so the user can really see where potentially it has been tampered with. And yeah, it is indeed the case that this is a tampered image. So without further ado, I'd like to stop here, but I wanted to say, if you'd like to see a live demo, a more in-depth of the very latest version of the plugin, please join us tomorrow morning for a live demo. Thank you.